Hello, welcome. In this short video, let us look at an example illustrating the long division method for finding the inverse Z transform. So given the following Z transform, x of z is equal to 1 plus 2 times Z inverse upon 1 minus 2 Z inverse plus Z power minus 2. So in the case of causal signal, that is when we assume that the inverse Z transform is causal, then we have to find it in the following way. That is, we first write x of z as two fractions. That is, first one is 1 by 1 minus 2 Z inverse plus Z power minus 2, and second one is, so the second part is 2 Z inverse upon 1 minus 2 times Z inverse plus Z power minus. So we have to find the inverse Z transform of these two fractions separately. So for the first term, we have 1 minus 2 Z inverse plus Z power minus 2, that is the coefficient, and the numerator is 1, and so the first term will be 1 into 1, so that we get a 1, so 1, and second part is minus 2 Z inverse plus Z power minus 2. And now upon finding the difference, the first term is 0, second one is 2 Z inverse minus Z power minus 2. Now in order to get 2 Z inverse, we have to multiply this for 1 with 2 Z inverse. So we have 1 plus 2 Z inverse here. So we have 2 Z inverse and then minus 4 Z power minus 2 and then plus Z power minus 3 and plus 2 times Z power minus 3. So the difference for the first term is 0 and second one is minus 1 plus 4. So it is 3 times Z power minus 2 and then minus 2 times Z power minus 3. So in order to get 3 Z power minus 2, we have 3 Z power minus 2 here. So 1 into 3 Z minus 2, that is Z power minus 2, gives 3 into Z power minus 2, and then minus 2 Z inverse into 3 Z power minus 2 will be minus 6 Z power minus 3, and finally plus 3 Z power minus 4. Again the difference will be, first term is 0, second part is 4 times Z power minus 3 and then minus 3 Z power minus 4. So to get 4 into Z power minus 3 with 1, when we multiply with 1, we have plus 4 Z power minus 3. So 4 into Z power minus 3, and then second term will be minus 2 into plus 4, so minus 8 Z power minus 4, and then plus 4 Z power minus 5. So the difference is 0, and then plus 5 Z power minus 4 minus 4 Z power minus 5. So the next term is plus 5. So the divisor is 1 minus 2 Z inverse plus Z power minus 2. So with this divisor, no, so the next term will be 5 into Z power minus 4. So this continues on. Now for the term 2, so for the term 2, again the divisor is 1 minus 2 Z power minus 1 plus Z power minus 2, and the numerator is 2 times Z power minus 1. So the first term will be 2 times Z power minus 1. So we have 2 times Z power minus 1 minus of 2 into 2 for minus 4 Z power minus 2, and then plus 2 Z power minus 3. So the difference, first term is 0, second one is plus 4 Z power minus 2 minus 2 Z power minus 3. So to get plus 4 into Z power minus 2, we have to have plus 4 Z power minus 2. So the value here is 4 into Z power minus 2 minus 8 Z power minus 3 and then 4 Z power minus 4, 0, and then 6 Z power minus 3 minus 4 Z power minus 4. So again the next term will be plus 6 into Z power minus 3, so 6 into Z power minus 3, and then minus 12 Z power minus 4, and then plus 6 Z power minus 5. So the difference is 8 Z power minus 4 minus 6 Z power minus 5. So you have another 8 into Z power minus 4. So again we will have 8 to Z power minus 4, and then minus 2 into 8, that is minus 16 Z power minus 5, and then plus 8 Z power minus 6. So the difference is 10 into Z power minus 5 minus 8 Z power minus. So the next term will be plus 10 Z power minus 5, and the terms and the division continues on. So there are two series that have to be added. So the combined power series for the x of z, that is the power series form for x of z by combining these two coefficients will be 1. The first term will be 1 plus 2z inverse. So we have 1 plus 2z inverse plus 3 into z power minus 2, 4 into z power minus 3, 5 into z power minus 4, and so on. So we write them here. So plus 3 into z power minus 2 plus 4 into z power minus 3 plus 5 into z power minus 4, and so on. And for the second term we have 2 into z power minus 1 plus 4 into z power minus 2 plus 6 into z power minus 3, 8 into z power minus 4, and so on. So therefore x of n from the power series expansion method, therefore the value of x of n from the power series expansion representation of x of z will be, the first term will be 1, second one will be 2 plus 2 4, and 3 plus 4, third term will be 7, 4 plus 6 10, and then 13, and so on. So that is the causal signal x of n. So the value at n equal to 0 is 1. Similarly, we can also find the anti-causal inverse Z transform. It is the anti-causal case. So term 1, then the divisor will be z power minus 2 z inverse plus 1. The numerator is 1. So the first term will be, we need to get a 1 from z power minus 2, so it should be z square. So it is 1, and then minus 2z, and then plus z square. So the difference is 2z minus z square. So to get a 2z, we have to multiply with 2 times z power 3. So 2z, and then minus 4z square, and then plus 2z power 3. Now the difference is 3z square minus 2z cube. So to get a 3z square, we need plus 3z power 4. So it is 3z square, and then minus 2 into plus 3 minus 6z cube, and finally 3z power 4. The difference is 4z cube minus 3z power 4. So the term here will be 4 times z power 5. So 4 times z cube minus 2 into plus 4, so 8z power 4, and then plus 4z power 4, z power 5. So 4z power 5. Now the difference will be 5z power 4 minus 4z power 5. So the next term will be 5 times z power 6, and so on. So the division continues. Now for the term 2, we have z square minus 2z inverse plus 1 as the divisor, and then 2z inverse as the numerator. So the first term will be 2z, so we have 2z inverse, and then minus 4z power. So the difference is 4 minus 2z. So to get a 4 here, we have plus 4z power. Here is a minus 2, so z power 2. So it is a 4 here, and then minus 8z power 1, and then plus 4z square. So the difference is 6z minus 4z square. So to get a 6z, we have to have 6z power 3. So it should be 6z minus 4, 6 to the 12z square, and then plus 6z cube. So difference is 8z square minus 6z cube, and then the next term will be 8z power 4, and so on. So to get 8z square, we need to have 8z power 4, so it is 8z square, and then minus 16z cube, and then 8z power 4. Difference is 10z cube minus 8z power 4. So to get a 10z cube, we have 10z power 5, and so on. Therefore x of z, we have two components, that is two power series. For the first term, we have z square plus 2z cube, 3z power 4, 4z power 5, and so on. So z square plus 2z cube plus 3z power 4, 4z power 5, 5z power 6, and so on. And for the second term, we have 2z, 4z square, 6z cube, 8z power 5, and so on. That is 2z plus 4z square plus 6z cube plus 8z power 4, 10z power 5, then 12z power 6, and so on. Therefore x of n for the anti-causal case will be, for z power 6, that is n equal to minus 6, we have 17, and then n is equal to minus 5, we have 14, and n equal to minus 4, we have 11, and n is equal to minus 3, we have 8, and n equal to minus 2, we have 5, and n equal to minus 1 we have 2, and n equal to 0 we have 0. So that is the anti-causal signal with values starting at n equal to 0 and then continuing with n equal to minus 1, minus 2 and so on are 0, 2, 5, 8, 10, 8, 11, 14, 17 and so on. So to summarize, we have looked at an example on the long division method for finding the inverse Z transform. So given the Z transform x of z equal to 1 plus 2 z inverse by 1 minus 2 z inverse plus z power minus 2, we can find the we found the inverse Z transform for both causal case and anti-causal case. So for the causal case, we have two terms. So term 1 is 1 by 1 minus 2z inverse plus z power minus 2, and term 2 is 2z inverse by 1 minus 2z inverse plus z power minus 2. So for the causal case, we write this one as the divisor as 1 minus 2z inverse plus z power minus 2, and the numerator is 1. So we start with 1 and 1. So the coefficients are 1, 2z inverse plus 3z power minus 2 plus 4z power minus 3 and plus 5z power minus 4. And then the second term, the numerator is 2z inverse, and so the divisor is 1 minus 2 z power minus 1 plus 5z power minus 2. So for the first term we'll have to have a coefficient 2z inverse, and then and then the next coefficients are 4z power minus 2, 6z power minus 3, 8z power minus 4 and so on. So the combined x of n, that is the inverse Z transform, is the combination of these two power series. So it can be obtained from the combination of these two power series. So the first part is 1, 2, 3, 4, 5. Second part is 0, 2, 4, 6, 8 and so on. So when we combine them, we get 1, 4, 7, 10, 13 and so on. That is the causal signal, which is the inverse Z transform of x of z. In the anti-causal case, we basically manipulate the divisor, that is we first write z power minus 2 and then minus 2z inverse and then plus 1. So to get a 1 with z power minus 2, we have to have a coefficient z square, and by using similar process we have plus 2z cube plus 3z power 4 plus 4z power 5 plus 5z power 6 and so on. Similarly for the second term, we get the coefficients 2, 4, 6 or 2z, 4z square, 6z cube, 8z power 4, 10z power 5 and so on. So to find the actual x of n for the anti-causal case, we combine the two power series, and then we look at the coefficients of these powers of z, positive powers of z. So we get in the reverse order, that is 0, 2, 5, 7, 8, 11, 14, 17 and so on. So with thus we can find the inverse Z transform of a given x of z, but both causal and anti-causal cases using the long division method. Thanks for watching.